We're in sunny Madrid. A very good morning to you, Miss Barla.
Good morning, good morning. How are you?
Really, really well. Thank you very much for taking the time to be with us today.
You're very welcome.
Have you seen there's one little monster here? Namito, this is Auntie Sheila. She does brilliant maths lessons. You want to watch this one?
I'm going to.
There we go. You've got 2 avid fans already waiting for you. We are streaming live to the country as well. If you are tuning in, streaming school is not normally so carry on streaming. We normally have things quite there, but apologies for Michael Gard dropping out this morning. Nisha, you still with us loud and clear?
Yeah, I'm here.
Wonderful. Okay, thank you so much, Miss Barla, for joining us. Please tell us a bit about yourself, because it's the first time we've got to meet you live.
Yes, well, I've been a maths teacher for over 10 years now. I currently live in Madrid, and I teach mathematics at GCSE level, and then I do a little bit of A-level and further maths as well. So I love maths, I love teaching. This is what I do. So hopefully you'll enjoy the lesson and you'll learn something at the same time.
And I feel really, really privileged, as with many of the people from streaming still, to actually say that Miss Barla is a very, very dear friend. Again, just as so many other people, just giving up their time, and with Miss Barla in particular, making time to be able to teach people all over the world. And I just love the connection that we have from now Spain and Japan and all the people volunteering. So thank you so much, Sheila. And yeah, really, really looking forward to your lesson. The floor is yours.
All right, great. Thank you very much. Well, I'm just going to share a PowerPoint that I started this morning. So what we're going to do, I'd like to explain a little bit about how I'd like to teach these lessons. So rather than teaching something that's very easy or very difficult, I'd like to go through the different levels. So you can understand each step, and you can see, even if you don't understand the topic at all at the beginning, hopefully by the end of all our sessions, you'll be able to do something simple, something a little bit more complex, and something even quite difficult and challenging, in your opinion, at the beginning. So today, we're going to start with factorisation, because this is quite a big topic in the Maths GCSE all over the world, internationally, in the IGCSE as well as in the GCSE. And in fact, in my opinion, I would count there being 5 different methods of factorising. So we're going to start from the quite basic one, and we're going to work our way through each one, okay? So just to give you an idea of what I mean when I say there's 5 different methods, here they are. So there's single bracket ones, which hopefully when I show you, you'll understand what I mean. There's something called the sum and product, you might have heard in a different way. The crossover method, difference of 2 squares, and grouping. We're going to see how far we get in the first 20 minutes of today's session, and then we'll continue them next Friday as well, okay? So the very first one is when I talk a single bracket. Now this one is quite simple in the sense that when you're looking at it, all you need to do is think of something that goes into both the things that you see here. Or if there's several different terms, you just need to consider what's the one thing that can be divided through everything. So in this particular one, we're just going to focus on numbers first. If you have a look at this one here, hopefully you can see that the multiple of 3 is in both. 3 times 1 is 3, and 3 times 4 is 3. So we can, over here, pull out, and I like to say pull out, which I mean by factorise out the number 3 to the front. So if you pull out the number 3 to the front, you write it like that, and then you think, what would you multiply your 3 by to get to 3x? So since there's only an algebraic bit left, you just write the x in there, yeah? Then the minus sign stays there because you're divided by a positive number. And then 12 divided by 3 is 4. So that's quite a nice simple one, I hope, for most of you at home, yeah? Okay, so let's have a look at the next one. So we're going to step them up. Each time it's a little bit more complicated, and we'll move on to the next type. So here, 20 and 24 both have a multiple of 4 in them. So we're going to divide both of these by the number 4. So again, you write number 4 on the outside, open up bracket, divide 20 by 4 and you get the number 5. The takeaway stays there in the middle. 24 divided by 4 is 6. So it's 6, and then don't forget the x on the end there. Okay? And then here, now this is a little one where you're going to think about algebra. So in both these, as you can see, the number, there isn't a number that's in both of them, right? There's no multiple in both. But there is an algebraic common factor in both of them. So we're going to pull out the x to the front. So in this one here, if you pull out x, don't forfeit and think that this is a number 2 that gets left here. X squared is x times x. So if you get rid of one of the x's, there's another x left over, right? So you're going to write the x in there. The minus sign again in this particular one stays the same. And then you divide 3x by x, which means you get rid of that x, and you just write the number 3 here. And now the very last one is a combination of the 2 things we talked about. So you've got to consider numbers as well as algebra. And normally when you get to this point, this is more like a GCSE question. These ones are introductory. These GCSE ones here, you've got to consider everything. And it's very smart if you check out the mark that they give you. If they give you 2 marks in this type of question, you realise that there are 2 different things you've got to do. So keep an eye out for that. Okay, so here, let's look at the number first. I notice that 12 and 18, there are two possible answers here. You could say the number 2 because they're both even and you'd be right, but there's a key word in this question that tells you what they're looking for. They say the word fully here, which means that 2 isn't good enough because you can pull out something even bigger, which is the number 4, because 12 and 18 both go into 4. So we're going to pull out the number 4 to the front. And if you look at both of them now, you can see that they have an x in common. So I'm going to put out the x as well. So there's 2 things here. When you're pulling out 4x, divide the 12 by 4, so you get 3. And divide the x squared by x, so you get another x there. Minus 9 in the middle again. And then the 18, the same thing. Divide the 18 by, I've made a mistake here. I'm thinking about another one I'm doing later on. 4 doesn't go into 18, does it? So here, this is number 2. The next page is the one I was thinking of. Sorry. So here you're going to put out 2 to the front. And next, I hope I haven't messed you up, guys, at home. So in this one, it's still a 2. So you pull out the 2 to the front here, so you get a 6 and an x. And then the 18, divide that by 2, and you get a 9. And then obviously you've taken the x away. Now, because you've divided by x, you don't need to write another number in here. So a quick thing to do when you get to this point, just like I nearly made a mistake, what you need to do is check your final answer. So the best way to do it is to do the reverse of factorizing, which is multiplying out. So that times that, 2 times 6 would give you that 12, and the x times the x combined gives you the x squared, so that's good. And then the last one, minus and minus gets stay there, and then the 9 times the 2x gives you the 18 and the x there, so you know you're good, and you get to move on. Okay, I hope that's okay. So let's have a look at slightly more complicated ones now. So these ones you can see I've stepped them up a bit, right? There's a little bit more complexity in these ones. So let's have a look at the very first one here. So here, this is the one where you've got to think about both. So look at the x's and algebra as well as numbers. So first, you should be able to see that there's a multiple of 7 here and a multiple of 7. But it's not just the number 7 that you can pull out to front. Can you see they both have a minus sign in them? So in fact, you can pull out the number minus 7 to the front. So that's a contraction both. And then similarly with the algebra, can you see that the letter A is in both of them? Yeah? So you get to pull out the letter A as well to the front. So here, if you divide by minus 7, a minus divided by minus gives you a plus. So you know it's a positive number, and it's number 3. And then here, the AB, you can just get rid of that A. So you've just got the B left over. Again, now be careful. This is a bit that a lot of students make a mistake on. You've got to still pull out that minus as well. So this minus also becomes a positive. Okay? And then divide by 7, so you get the 2. And be very careful here. Here, when you divide by A, it's technically the number 1. But because most of the time when we write algebra, you don't write 1x, you just write an x down. So it's the same here. You don't need to write the algebra down. You just write the number 2. And if you want to do, you can do a quick check. That times that, yep, minus 27, 20, everything. Okay, so all of them, what is the same thing that can be pulled out of all of them? And here, if you look carefully at this one, you can see that the number 5 can be extracted from all of them. So I'm going to write the number 5 in front. Divide that, you get x squared. Divide that by 5, you get minus 3x. And if you divide this by 5, you get minus 4. Okay, now in this particular case, I'm going to just put a little star next to this. There may potentially be more that you can do here, but for now, we're just going to stop there because I'm just teaching the first method. But keep an eye on this, okay? So keep an eye on this. Whenever you get a quadratic like this, where you've got something with x squared, x's, and then a number, you've got to consider one of the other methods of factorizing. So you might come back to this question later on. But for now, I'm happy with that just being my answer for this one. Okay, now this one, this is where I'm talking about a little step up. So this is one that somebody might have not seen before. So let's have a look at it. Here, there is something you can pull out. It's just written a little differently. And if you look at all of these, you're looking for something that was the same in everything, right? If you look here, can you see that, although it looks a little odd, can you see here that the x minus 1 and the x minus 1 is the same in both of them? So even though it's a little bit more complicated in terms of algebra, you can pull that whole chunk out to the front really easily. So you can write down, make sure it's in brackets because it's all connected, right? You can pull out that x minus 1 to the front. And now I tend to, with these ones, so look a little bit more complicated, is cross out the bit that I've already pulled out to the front. And I'm going to cross out that one. So then hopefully you see the rest of the answer very clear. So you can see that it's 4 plus a that's left over. So it's 4 plus a as the second part of that quadratic expansion.
Did we just hear a Madrid ambulance going?
Yeah, there's quite a few around here. Didn't realize it was so loud.
Well, yeah, for everyone, international. If we wanted to hear what an international fire engine or ambulance sounded like, now you know.
There you go. Teaching a little bit of everything, aren't I? So here you pull out the x minus 1, and then you get the x plus 4, a plus 4 here as well. Okay, so that looks a little bit more complicated, but it's exactly the same method. So really not much to be stressing about. Okay, and then the very last one here, we're going to merge everything together. So here you've got 3 terms. You've got to consider the algebra as well as the letters. So let's add the numbers. So let's look at the number bit first. If you look here, it's a 6, a 9, and a 12, and hopefully in your head the number 3 is popping up. So I'm going to write a 3 in the front. Okay, and if it helps, I'm going to just do it for this one. Divide that by 3, I get a 3, so it's just helping me for later on. Divide that by 3, I get a 2. Dividing that by 3, we get a 4, right? And if you look at the algebra bits, you've got to look very carefully here. If you look here, you've got the x's as well as the y's that we factorised to the front, right? And if you look, there's 2 x's here, x squared, there's an x here and an x here. So the maximum I can pull out to the front is just an x, yeah? And then with the y here, a y here, but a y squared there. But the maximum that's in all 3 of them is just 1 y. So I'm going to write down 1 y at the front there. So when you're doing this, you've got to remember you've got rid of one of the x's there, one of the x's there, and one of the x's there. You've got rid of one of the y's, one of the y's, and one of the y's there. So you look at what you've got left over, which is a 3 and that little x there. So it's the 3 at the front, and then the x goes inside here. The sign stays the same. Here, that 2 and nothing else. Can you see everything else has been deleted, yeah? So it's just minus 2. And the last one, the y, the 4's there and the y's there. The x has been removed to the front, so it's just plus 4x. Okay, so that would be probably the worst case scenario when it comes to single brackets. These 2 are probably the most difficult ones when it comes to single bracket factorization. So let's have a look at some questions that I'd like you to have a go at. Now, you probably won't finish all of them in the time I'm giving you, but if you want to take a screenshot of the page so you can try them later on, I'm going to show you the answers too. But I'll give you about a minute to have a go as many of these as you can. Okay, so here you go. Have a go at these ones and let me know what you think. Okay, have a go. Let's consider this algebra as well as numbers, so you can pull out to the front. I'm just letting them have a go at a couple of these questions now and see how they find them.
It's Dina's birthday, so people have been sending presents. It's going to be knocks the whole time.
I can imagine.
Apologies.
Okay. I hope you bought her something nice yourself.
I know you're pretty surprised that you know, we're just being casual, but that's how it is on streaming school. We just knocks and kids, and it's quite cool.
Yeah, I like it. I like it.
I don't even know why I'm whispering.
I don't know either. We're letting them concentrate.
Do you know what? It's because you feel like there's teachers in a lesson while the kids are supposed to be doing work, and if you're ever that in an exam hall, you're like.
I know it comes naturally. You don't even realise you're doing it.
Honestly, I remember, like, to share something guilty. I remember once literally saying to it, I'd read something over a kid's, over a student's shoulder in an exam, and I remember going to one of my colleagues and said, "You have to go and read over the." It was a mock exam. You have to go and read over the child's shoulder. So, yeah. Sorry to interrupt you.
Okay. Yeah. Right, I hope I'll give you a little bit of time to try a few of those. Some of you might have gone right to the bottom, but I'm going to show the answers to these because I would like to go on to the next method, at least to introduce you to that today, okay? So here are the answers for each of these. So if you look, the first few are not too bad. It's just numerical extraction from the front of this, factorizing to the front. It's a little bit of both, the 6 and the y. Make sure you pull out a 6 because it's fully factorized, not the number 2, not the number 3, but you've got to pull out the whole 6 at the front. That is a 2 and a b. And then when you get down to these bottom 2, these are the ones that are really smart. You've got to notice the entire factor, the bit that's in the bracket has to be pulled to the front. And whatever you've left over goes in the second bracket. Okay, so that's the first method, right? Out of 5. So let's have a look at the second method. This is the one that starts stepping up. So first of all, you need to understand that you need to see a quadratic, okay? A quadratic means, in this particular case, each term of the quadratic. In a quadratic, definition of quadratic is a polynomial where the highest power is the number 2, right? So you've got an x squared in there. you've got an x in it, and you've got a number. You've got to have 3 parts for this one. And this one, I've said in the title, is where the coefficient of x squared is the number 1. In basic terms, all I mean is there's no number in front of the x1. Technically, there's a 1 here, right? The x squared, coefficient is numbers in front. But in this particular one, I count it as there's nothing in front of the x squared, okay? So in this particular one, you've got to consider, it's called the sum and the product. So what you've got to think of, and the best thing to do always, is start with this last number here and consider 2 numbers that multiply to give you positive 6. Now, those same 2 numbers have to add up to give you positive 5. So they'll think about them. Generally, they tend to pop into your head immediately, I hope. So in this particular case, it's a nice simple one for this one. So 6 can either be 1 and 6, but the most likely ones are the number 2 and the number 3. Because obviously when you multiply them together, you get 6. And just check that 2 plus 3 also gives you the number 5. Okay, obviously I picked a nice simple one where numbers you can spot for this one, but there's going to be far more challenging ones later on that you've got to be really on the ball for. Pardon?
No, that was just the next teacher jobbing in. Don't worry about a thing.
Okay, so here, the number 2 and the number 3 are the 2 important numbers, right? So all you do is the same layout as always. With quadratics, you'll always have 2 brackets, okay? The first part of both brackets is the part that comes from the x squared. So the x squared gets split into 2, where you get an x here and an x here. And if you notice, I did say it before, but I didn't make it emphasize properly, but both of these numbers are positive. So all you do is you put into one of the brackets one of the numbers, but you know it's a positive 2, and into the other bracket you put the other number, which is positive 3. So there you go. That is the factorization of this. And obviously we're not going to go through this today, but what you can do to check your answer is expand it out. So you can use FOIL or whatever method you've been taught at school to expand out and simplify. If you have time in the exam, you can check that it actually does give you the answer x squared plus 5x plus 6. All right, let's have a look at another one. So the second one here is very similar. These 2, notice how this one's positive, so you don't need to worry. All the numbers are going to be positive, but here we've got a negative number here, so you've got to be a little bit more careful. So let's do the first one. And quickly, there's 16 here. We're going to think of 2 numbers that multiply to give you 16. And exactly the same 2 numbers must add to give you 10. So the product is 16 and the sum is 10. And hopefully you can spot that the 2 numbers here would be the numbers 8 and the numbers 2. So 8 and 2 multiply to give you 16, and they add to give you 10. So again, the same layout. 2 brackets. The x squared tells you that the front of both the brackets you write an x in. And again, just in this case, all the numbers are positive, and our 8 and our 2 are both positive as well. So it's positive 8 here and a positive 2 here. And that's it. Again, you can check by doing FOIL or any expansion method that you've learned at school to make sure the answer definitely is this. Okay, right, let's look at this one now. So this one, you've got to be a little bit more on the ball here because it's a negative number. So 2 numbers that multiply to give you minus 14. So multiply to give you minus 14. Think one of them needs to be negative, one of them needs to be positive, because a minus and plus make that negative sign. Yeah, but at the same time, when you add them together, you've got to get positive 5. So think of it in this way. The positive number needs to be more than the negative number so that they cancel out and still give you a positive answer when they add. What I tend to do, and I'm guessing it's probably the easiest way actually, is I think of just 2 numbers that multiply to give me 14. So I don't stress. I just write down the 2 numbers I think multiply to give you 14, which can be 2 and 7, could be 1 and 14, but that's not going to give you a 5 when you add them together, right? So 2 and 7. And then I know that I need a positive 5 when I add them together. So I realize that 7 has to be positive to get you high enough. And then you take away that 2. So 7 take away 2, voila, is 5. Minus 2 and 7 multiply to give it to 14. And the same layout again. It's nice and easy after that. Got the 2 brackets. You write an x in front of both because of the x squared. And here, it doesn't matter which one goes first. It doesn't matter even here either. I'm going to put the plus 7 first because I feel like it. You put the minus 2 first if you wanted to. And then the minus 2 at the back. And again, you can expand that out and check that it matches up with that. How are we doing for time?
It is 1 minute to go.
1 minute to go. Okay, so let's try one more. Okay, I think we'll squeeze one more in really quickly and just see. Here, let's have a look at this one. We're going to leave that one. You can have a go at that at home. Let's have a look at this one. So, same method. Consider the minus signs. Be careful. 2 numbers that multiply to give you minus 40. If it's a minus number, 1 has to be minus, 1 has to be positive. But here, when you add them together, you've got to go down into negative numbers. So your negative number needs to be bigger than the positive number, right? So again, I just consider numbers. So I'm thinking it could be 8 and 5. I'm going to write this down for a second. But then they would not get you a 6 in any way at all, so that's not right. And then I think of 4 and the number 10. And you can see here the difference between them is that 6 there. And you want to make it, when you add them together, it's got to be a negative number. So you've got to make the 10 negative and the 4 positive, so it stays negative. And then you draw your little 2 brackets. The x squared tells you it's an x in the front, x in front. And now we can put a minus 10 here, or the plus 4 up to you entirely, and then put a plus 4 on the other one. And there you go. All right. So with this, there's a link to more questions that hopefully Laura's going to be able to upload for you to have a go. And next Friday, so this time next Friday as well, we'll continue with these slides. So by the end of hopefully 3 sessions, you'll have covered everything you need to know about factorising and you'll be good. Okay, I hope that was useful. Thank you very much.
Thank you so much, Sheila. It's really, really appreciated. You're really, really kind. Enjoy the rest of the day in sunny Madrid. And tiny apologies from me. I didn't cut the stream before we moved from maths to English. So I'm going to cut that video up and put it up separately so it'll be there for you to watch a little later on today.
Great. All right then. Thank you.
Thank you. See you again.
Bye.
Bye.